Okay, can you able to see the screen? Can you able to see the screen?
Yes, sir.
Yes, sir.
Okay. Okay, so up to the last class we had discussed the mechanical system. Okay, so what are the two types of mechanical system discussed so far? What are the two types of mechanical system?
Translational and
Translation and
rotation.
rotational system. So what are the three elements in mechanical system? Three elements. The three elements. What are the three elements to represent the mechanical rotational as well as mechanical translational system?
Mass, spring, and
Yes,
dashpot.
mass, spring, and dashpot. So I hope you are very clear in the previous concept, because of the next electrical system is it is a continuation of the previous two systems, mechanical translation rotational system. So we are going to discuss only the mechanical translation system with a continuation to the next electrical system. So just I give the short introduction and they will move very fast, right? So electrical system is nothing but it consists of only three components: resistance, capacitance, and inductance. So resistance, which opposes the flow of current, and inductance opposes the rate of change of current, and the capacitance, which will be stores the energy. So these three have the different characteristics. So the electrical system, entire electrical system is made up of only these three components: resistance, capacitance, and an inductance. So, and two more quantities. Only the two quantities in an electrical system is one is voltage, another one is current. So the next coming topic we are going to discuss with the five parameters: resistance, capacitance, and inductance. These are the elements of the power system, and the two states of the electrical system is one is voltage, another one is current. Okay, so I already explained. Resistance means opposes the flow of current, and capacitance means it stores the energy in the form of charge, and inductance, which opposes the rate of change of current. So regarding the current and voltage, so what is meant by voltage? What is meant by current? So these five are we already studied in the physics. Just I give the one line expression for that. What is my voltage and current? So what is meant by current? What is my current means the flow of electrons. The flow of electrons is called as current. Simply, the flow of electrons is called as current. The voltage, what is my voltage means the force required. The force is required to move the electron. Okay, the force is required to move the electron in the conductor, or it may be in the semiconductor. That force is called as voltage. Okay, so the flow of electrons in a conductor is called as current. The force required to move the electron, that force is called as voltage. So this is the overview of electrical system. We will move to the next slide. So again repeating, the mechanical translation system, it is a continuation that is moving to the electrical system. So first one, the models of the electrical system. The models of electrical systems are obtained by the three elements. The three elements is resistance, capacitance, and inductance. So already you know that. So the characteristics of the elements, each element, resistance, capacitance, and inductance, in terms of voltage, in terms of current. Okay. So in terms of voltage, in terms of current is given in the table 1.1. So first one, for modeling of the electrical system, electrical network equivalent circuit, the overall electrical power system is made up of only these three elements: resistance, capacitance, and inductance. And the main states of the system, states are voltage and current. So based on this, we have to derive the same whatever we did in the previous topic. We have to derive the differential equation for the system, and finally we have to find out the Laplace transform for electrical system. So previously we have derived the differential equation, then applied the Laplace transform, convert that differential equation into algebraic equation. So finally you have find out the Laplace, the transfer function, that is output of the system divided by input of the system. Same exactly what you have did for mechanical system. Next we have moved to electrical system. Here, instead of mass damping, that is a dashpot and spring, we have the three elements: resistance, capacitance, and inductance. Okay, so there we discussed the force. There we discussed the force and torque, but here we are discussing voltage and current. So this is the analogy. Analogy means equivalent. That's only we are shifting from mechanical translation to electrical system. Again, repeating, there are three elements in the system: mass, spring dash pot. Here the three elements are resistance, capacitance, and inductance. There we discussed the force balance equation, torque. These two are the discussed states of the system. Here voltage and current are the states of the system. So come to the table. The first one is resistance. So resistance and inductance and capacitance. So the first one, relation between the voltage and the elements of the system, and the third column represents the relation between the current and the element. So you see that the first one, voltage across element, you know that V equal to I of t into R, or R into I of t. So next, for inductance, V of t is equal to L into d I of t by dt, and for capacitance, 1 by c integral of I of t into dt. So for the current relationship, what is the relation between the current and the resistance is I equal to V by R. But see that the current relation between inductance and the current is I of t equal to 1 by L integral of V of t into dt. And for capacitance, C into dV by dt. So the inductance property and the capacitance property is exactly opposite for the voltage and current. So we have to see the opposing characteristics of inductance and capacitance. So here the voltage is L into d I of t by dt. For the capacitance, it will be I equal to C into dV of t by dt. So same thing, the current as well as the voltage across the capacitor. So yeah, any doubt? Shall I move to the next topic? This is the basic fundamentals of electrical system. What is the relation between voltage and current, resistance, capacitance, and inductance? Shall I move to the next slide?
Yes, sir.
Okay. So the first one is one example tutorial problem. So previously you have we have approached the mechanical transfer rotational system, how we are deriving the transfer function. So now it is simple electrical circuit. Since we already studied the electrical circuit analysis, so that it is easy to understand. So it consists of one electrical circuit. It has only one input. The input is E of t. So this is your input. E of t is your input, and it consists of two resistance R1 and R2, and two capacitances in parallel C1 and C2, and your output is V2 of t. So this is your input side, and this is your output side. Okay. So now, what is the question? Obtain the transfer function of the electrical network. That is output by input. That is V2 of t divided by that is input of the E of t. So output by the voltage across the capacitor, and then the input is E of t. So how many nodes in this circuit? How many nodes? Two nodes. So you know that Kirchhoff voltage law and Kirchhoff current law. So using the Kirchhoff voltage law and Kirchhoff current law, we are going to simplify this circuit. Since it consists of the, we are going to solving this problem with a node analysis. So which law to be applied, whether it is a KCL or KVL for node analysis?
KCL.
KCL, exactly. So Kirchhoff current law we have to be applied, and since there are two nodes, for each node you have to find out the equation based on the KCL, and you have to find out the transfer function of the electrical network output by input. So I will go step by step. Later you can practice by solving the problem, and this is not a main problem. This is the preliminary problem. Okay, it is a preliminary problem. So I hope you understand the circuit, or you can draw the circuit in your paper, so that in the next slide it will be easy to for you to refer the problem. So it consists of only one input source E of t, two resistance R1, R2, and two capacitance C1 and C2. It consists of two nodes. We are going to apply, that is what we studied in the circuit analysis. Apply the KCL and find out the two node equations, then solve the equations and find out the output by input. So whether you take a paper and draw the circuit, or you can move to the next slide. So our objective is to obtain the transfer function. That is, what is your output ratio of output by the input of the network. So it is better you can draw the circuit in a paper. Once you finish, means tell me. I will move on to the next slide. Finish the diagram. Will I move to the next slide? Will I move on to the next slide?
Yes, sir.
So based on the previous circuit, so your output is V2 of S. That is, we are talking about the Laplace transform based output. So V2 of S divided by E of S. So don't even by a silly mistake or don't be careless. If you put V2 of T divided by E of T, it is not a transfer function. Laplace transform which converts the time domain into frequency domain. Okay. So your output, the transfer function of the network is what is the output? That is V2 of S divided by input of S is only one voltage source, that is E of S. So now we are going to approach this problem. So you put that we have to find out the Laplace function, that is a transfer function of the system V2 of S divided by E of S. We have to find out this ratio V2 of S divided by E of S. So now I am moving on to the problem solving, first step. So I hope you all have drawn the diagram. So you know this, how to convert the voltage source into current source. So you see the first one, it consists of one voltage source series with a resistance. So in order to convert this voltage source into current source, the current source should be connected in parallel with the resistor. So why we are converting the voltage source into current source? We are talking about only the current source circuit. So we need to convert all the voltage source into the current source. Since there is only one voltage sources, we have to first convert it into the current source. Based on that, you can apply the KCL and find out the first node 1 equation, then apply the KCL for the node 2 equation and solve the two equations. Find out the ratio between the output by input, that is V2 of S divided by E of S. So you please note on first step is, since there is a voltage source, we convert into a current source so that it will be better to be solve the problem and convert into the transfer function. So take the first circuit, apply the conversion concept, that is how the voltage source into converted into current source. So if the voltage source connected with the series with the resistor, while it is converted into current source, the resistance should be parallel with the current source. So voltage source series with the resistor. While we are going for the current source, the resistance should be connected in parallel with the current source. Shall I move to the next slide? Any doubt in this slide? How to transform the source, voltage source into current source, source transformation?
Sir, 1 minute, sir.
Okay.
Sir, rest half of the circuit will be same.
Yes, rest of the circuit will be same because there is no voltage source or current source. You have only one input. See, if you have any question, please ask me, because of electrical system is somewhat slightly complicated because of we are moving from mechanical system to electrical system. So same mechanical system, you have to draw the equivalent electrical system using resistance, capacitance, inductance. So I will give the circuit of mechanical system, mass, spring, and damper. You have to draw the electrical equivalent circuit for the mechanical system. So be clear in that what is meant by voltage source, voltage, current relation with respect to inductance, capacitance, and resistance, how to apply KCL, KVL. So everything should be clear because I will give only mechanical system. You have to convert into electrical system with the electrical components. Okay, I later tell you how to equate mass is equivalent to water, spring is equivalent to water, dashpot is equivalent to water. I will clearly explain. You have to remember that three elements is exactly equal to resistance, capacitance, inductance. Let's finish. Shall I move on to the next slide? Shall I move on to the next slide?
Yes, sir.
Okay, first one at node 1, you know how to apply the KCL. So the V1 is considered as a node 1. So based on this node 1, you see that we have to write the equation, that is a KCL equations. So the first one is you have to keep input signal, data on one side and output data on another side. That is the input current as well as the output current. So the first one is V1 by R1 plus the current flowing in the capacitor, that is C1 into dV1 by dt plus V1 minus V2, another node. So consider this is the another node, V1 minus V2 divided by R2 equivalent to, and this is your input. So this current source is the input side. So input current source equal to output current. So first one, input side is we have only one current source, E by R1. This current is splitted into V1 by R1. So one current on V1 by R1 and another one is on capacitance side. So C1 into dV1 by dt plus V1 minus V2. So this node is a V2 divided by R2. So next you are taking the Laplace transform V1 of S divided by R1, and for the first derivative, you see that C1 S into, that is S into V1 of S plus V1 of S minus V2 of S to R2 was equal to E of S by R1. So from this equation, you are deriving the expression for in terms of V1 of S. So you once again check it at node 1, practice yourself how to apply the KCL and write the equation for the node 1 in terms of current.
Sir, what about C2, sir?
What about C2? See, C2 is coming under the node 2, right?
Sir, but still the current is dividing for the C2, no, sir? At V1.
No, man, we are considering
At
only V1
R2,
node. Yes,
sir,
or
but at R2 the current is dividing.
yes, it will be considering under the V2 node.
Okay.
Okay, it considered under the V2 node only. I am putting just imaginary, that is V2 will
Sir,
be
it will
there.
be C minus C1 under V2 node.
V2, what man? V1 minus V2 divided by R2.
No, sir, under V2 node. The
Under
current
V2,
will be divided, right?
yes, you finish this means, shall I move to the next slide? V2.
Sir, no, sir.
Okay, you first complete this. See, at node 1, you cross check whether the KCL equation is exactly right or not. At node 1, you write for all the elements. For all the elements, the current is divided. You write the equation, then cross check it whether it is tallying or not. See, again repeating, this control system is a basic, fundamental, important part in your gate examination. Shall I move to the node 2, V2?
1 second.
Okay.
Okay, sir.
Okay. So coming to V2, now considering the V2 node alone, you see that, so V2 minus here the node is V1. So assume it is an imaginary, it is a V1 node. So while considering the V2, you have to start from V2 minus V1 divided by R2, because this resistance is R2. So V2 minus V1 divided by R2 plus the current flow through the capacitor C2 is C2 into dV2 by dt equal to 0, since here there is no input source. So for this equation, taking the Laplace transform, that is V2 of S minus V1 of S divided by R2 of S plus C2 into S into V2 of S equal to 0. So now we are getting the equation in terms of V1 of S. So this equation to be substituted in the previous equation, that is equation number 1, to get the output divided by the input transfer function. Okay. So put the equation 2 in equation number 1. So in the equation number 1, put the equation 2 in equation number 1 and find out the output of S divided by, that is the output voltage divided by the input voltage. So any doubt in this? How to apply the KCL for this? How we are getting the KCL for the node 2? So after finishing this, you substitute the equation 2 in equation number 1. I finished this. I'm on next slide.
Yes, sir.
See. So now you have to substitute the equation from 2 in equation number 1. You can find out the ratio, that is V2 of S divided by E of S. So you please cross the equation whether you are getting the V2 of S divided by E of S. So this is the final expression. So the first two one represents the differential equation. That is, for node 1, what is the differential equation? For node 2, what is the differential equation? Next, you have to apply the Laplace transform for the differential equation. Then substitute the equation number 2 in equation number 1 and find out the V2 of S divided by E of S. So please note on the final equation, and later you cross check that whether you are getting this final expression V2 of S divided by E of S. Please note on this equation. Later you can cross check whether you are getting this equation or not. V2 of S divided by E of S. That is output of the system divided by input of the system. So this is the transfer function of your electrical network. So now you know that if any electrical network is given to you, first you have to find out how many number of sources, how many number of nodes, then apply KCL, then find out what is the input of the system, what is the output of the system, determine the transfer function of the system.
So without source transformation, we can't do.
Yes, you can do applying the KVL. Sometimes if two sources will be given, here the problem consists of only one source. Suppose two sources will be given, means what you will do? Any idea? In this problem only.
We consider two loops and then.
Yes, you can consider the two loops. You can determine the output. Sometimes in that cases, what they will do, they will specify this is the output, this is the input. You have to find out the ratio of that output voltage divided by the indicated input voltage. Okay, you understand the problem? Here it is only one source, so automatically another side will be the output. So we will determine the transfer function output side by input side. Suppose if the two sources are given, like in superposition theorem, two sources will be there. The question itself they will ask for which output divided by which input. We have to find out that ratio only. Clear? Shall we enter into the main topic? Electrical system, main topic. So you note down this equation, V2 of S divided by E of S. Shall I move to the next step? You please write this equation and cross check the equation whether you are getting or not. Shall I move to the next step? Shall I move on next section? Finish writing this equation.
Yes, sir.
So from this only our main topic, that is electrical analogous of mechanical translation systems. Okay, so what we are going to discuss in the next coming slide is, a mechanical system will be given. You have to draw the electrical equivalent circuit for the mechanical translation system. Okay, so that is the meaning of electrical analogous of mechanical translation system. So a mechanical translation system consists of three components: mass, spring, dashpot. A mechanical system will be given to you. You have to draw the equivalent electrical circuit for the mechanical translation system. So now you can have one question: why we have to draw the electrical equivalent for mechanical system? Because this electrical concept is universally accepted and everyone can able to understand the concept of the electrical system. So that's why any system which is given to that engineer, they will convert it into equivalent electrical system. So this is the meaning of analogous. Analogous means equivalent circuit or approximate circuit. A mechanical circuit is given, you have to draw the approximate equivalent circuit for the mechanical system. Okay, so the first one, the analogous given is so as long as the differential equation governing the system, that is the two system has a same differential equation and as well as the same transfer function. So that's only given in the first point. The system has a analogous as long as the differential equation governing the transfer system as well as the transfer functions are identical form. So here the mechanical system consists of three elements. See, mass, dashpot, and spring. Same thing, electrical system also, it is analogous to resistance, inductance, and capacitance. So from this, what we are inferring, mass is equivalent to resistance, dashpot is equivalent to inductance, and spring is equivalent to capacitance. So mass here, mechanical system, mass means in electrical system, it is a resistance. You should never forget in your lifetime. Mass in mechanical system means resistance in electrical system. So dashpot in inductance means, sorry, dashpot in mechanical system means equivalent element is inductance. Spring in mechanical system, the equivalent element is capacitance. So these are the analogous between the electrical and mechanical system. So another one is, you can see the important difference. There we discussed the force balance equation. Force balance equation we discussed in the mechanical translation system. But this will be in electrical system, it will be a voltage or current. It will be a voltage or current source can be used to represent the input force. So all the students, I request from this section onwards, very important topic is starting. If you have any doubt, please ask. So three elements in mechanical system: mass, dashpot, and spring. Equivalent elements in the electrical system is mass is converted into resistance, dashpot is converted into inductance, spring is converted into capacitance. Here the input is force in mechanical system, but in electrical system you can use voltage or you can use current also. Both are equal to the force. So you see that the output velocity, this is another important point. Output velocity is the first derivative of the displacement. Okay, so the displacement is x. First derivative means dx by dt. That is the first derivative. This is in case of mechanical system. But how we are expressing in the current or voltage in terms of electrical system, we have to take the double derivative in electrical system. So next, since electrical system has a two input, whether it may be a voltage source or current source, therefore there are two types of analogy: force voltage analogy, another one is force current analogy. Okay, so any doubt? We have observed the three important points: mechanical system, mass, spring, dashpot. Equivalent electrical system, for mass it will be a resistance, dashpot it will be inductance, spring it will be a capacitance. This is the first important point. Second important point is, here we discussed the force. Force is the input. That's only we discussed a force balance equation. That is input force equivalent to opposing force. But in electrical system, you can take two quantity, whether it is a voltage or current. Both also represents the force, voltage or current. So third important point is displacement. X, the first derivative of the displacement which represents the velocity. So you have to equally consider for voltage and current also in electrical system. And last one is, the overall electrical system is divided into two types: force voltage and force current analogy. Why? Because force can be represented in both the terms, force voltage as well as force current. That's why it is represented in force voltage and force current analogy. Shall I move to the next slide?
Sir, for the output velocity, what is like double derivative? What you told again?
So the first derivative of displacement is actually this is the velocity, so that you have to take the first derivative. But acceleration, the next quantity, means you have to consider as a double derivative.
In electrical system, that is
In
equivalent.
equivalent acceleration equivalent. Here it is a velocity, so that you have to take the first derivative in electrical system. As a simple matter is, in mechanical system, x is the displacement. First derivative is the velocity. The same first derivative only you have to consider in electrical system.
There is a first derivative of what?
First derivative of
Current or voltage is considered as output
voltage
velocity.
or current. For both, you have to consider the first derivative.
Okay, sir.
Okay, you have to consider here the displacement x means you have to consider the derivative. Okay, here the forces you are given. So a object is moving at a certain distance at a displacement of x. But for electrical system, the same force you have to take the dx by dt, not simply SI x. So here mechanical system, I am giving a force. So based on the force, the mass element m is moving at a particular distance x. But here in the electrical system, a force is given, but you have to consider dx by dt, that is dv by dt. So you have to take the first derivative. Here you have to consider x, but you have to consider dx by dt, electrical system. That is the difference. So shall we move on next slide? Shall I move on next slide? You have any doubt in this? Mechanical to electrical system. Yes, any doubt? Yes, any doubt? Shall I move on next slide?
Yes, sir.
So the same procedure what we have discussed in the mechanical translational as well as mechanical rotational system, we have the list of procedures how to proceed the problem. The same thing is the guidelines are given for the first cases force voltage analogy. So first we are discussing the force voltage analogy. First thing is force voltage. First one, this is the second case. Okay. So first one discussing the force voltage analogy. So you see the first point, in an electrical system, we know that there are two types of connections. One is series connection, another one is parallel connection. In series connection, current is same. In parallel connection, voltage is same. The same concept applicable to here also. There is no difference. You see the first point, in electrical system, the series will have the same current. Likewise, in mechanical system also, velocity are said to be in series. This is the first point. And second point, elements have the same velocity in mechanical system should have the same analogous current in electrical system also. Here the current is equivalent to velocity. And third one, node. What is my node? You have studied the node and mesh. Node analysis as well as mesh analysis in circuit theory. So node means the meeting point of the element in mechanical system corresponds to the closed loop in the electrical system. You remember that node means in mechanical system it is a M. M represents the node. That's only we targeted only the mass. What are all the elements connected to the mass? The M is considered as a node. The same system, the electrical system is, you have to consider the closed loop in the electrical system. Okay, and the last one, the number of meshes in the electrical analog is the same that of number of nodes in the mechanical system. So that is the fourth point is very important. Mechanical system nodes, electrical system meshes. So this should be equivalent number. Hence, the number of mesh current and the system equations will be same that of number of velocity of nodes in the mechanical system. So I hope you remember these points. The first one is series connection. Current is same. Voltage in parallel connection, voltage is same. So in series circuit, in what way the current is same means the same thing in mechanical system. Velocity also constant. And second one, the velocity should have the same analogous to the current in the electrical system. Third one, meeting point in the mechanical system is node. That is, we are consider the node in mechanical system, but for electrical system, we will consider the closed loop. And the last one, number of closed loop equal to number of nodes in the mechanical system. So I will give the mechanical system diagram. You have to draw the electrical equivalent diagram for the mechanical system. It's the simple thing. Mechanical system, I will give the diagram. That is mass spring damper. You have to equivalently draw the electrical system considering these guidelines. You have to consider these guidelines as well as transformation. Resistance means mass. Inductance means dashpot. Capacitance means spring. Just to replace the element, draw the diagram and show the equivalent diagram. Okay. So this is the level of design thinking. I hope you hear this word, design thinking. How you are thinking related to the design. Your guidelines are given, transformation also given. Considering the both, draw the circuit. Part C is over. I don't know whether you are appearing for part C or part A only. Shall I move next slide? Remaining only 2 points only there. Yes, any doubt? Shall I move on the next slide? Force voltage analogy. So first section is force is converted into voltage. Shall I move to the next slide?
Yes, sir.
So the last 2 point is mechanical driving sources, force, because there the force is the input. And connected to the node should be represented by analogous element of closed loop in analogous electrical system. That is, what are all the elements in the mechanical system? Mass, spring, dashpot should be represented in elements in the electrical system. That is the 5th point. And the last one is element connected between the two masses in mechanical system represented by common element between two meshes in the electrical analogous system. So in mechanical system, we talk about the node. In electrical system, we talk about the meshes. So if there are any element connected between the two nodes, it should be represented as an electrical element between the two meshes. Okay. So these are all the 6 points given for force voltage analogy. Mechanical system is given. We have to convert the system into electrical system in terms of voltage. So keep remember that in terms of current, that is different. Mechanical system is given. You have to convert that mechanical system into electrical equivalent diagram in terms of voltage. In terms of current, it will be completely different. Shall we move on to the conversion? How the mechanical system is converted into current, that is voltage. Equivalent diagram. How to convert the mechanical system into electrical equivalent system in terms of voltage. That is yes. So next, you please go through it very fast. It's very simple one. The first one, analogous elements in force voltage analogy. So you already studied this. Mechanical system, what is the input? It is a force. Output is velocity. An electrical system, input is voltage source. Output is current through the element. That's only I explained. What is meant by voltage and current is, current means flow of electrons. If you take any wire, the flow of electrons is called as current. The force required, a force is required to move the electron in the wire, that is called as voltage. Until there is no force, there is no flow of electrons. That's only you have studied the physics, EMF, electromotive force. The force is required to move the electron in the wire. If there is no force, the electrons will be in a stationary in the wire. It will not be, there is no movement of the electrons. The movement of electrons we are studying as a current. The movement of electrons is called as a current. Okay, so that is the first row. Second row, you listen carefully. It is a dashpot. The dashpot is how it is equivalently transformed into electrical system. So a force is an input. You see the dashpot B, and above the dashpot you have the displacement x and velocity. You have the two indications. In previously mechanical system, we have only displacement. In dashpot, it consists of x as well as v. So this velocity is represented by first derivative dx by dt. So the force is given by b into dx by dt equal to b into v. That is the velocity. How we are getting the velocity? Taking the first derivative of displacement. So this is the equivalent electrical diagram for your mechanical system. So instead of force, this force is converted into input voltage because we are studying force voltage analogy. Then the dashpot is the current, the gas part is converted into the resistance with E equivalent to V and V equivalent to Ri. Okay, so E equivalent to R into I. So next, the mechanical system. Mechanical system is how it is equivalently converted. So here the mechanical system, you see that it consists of two quantity, x as well as the acceleration. So displacement is x and the acceleration is given by d square x by dt square. And the last one is spring. The spring is transformed into the capacitance. So here the both the displacement x as well as the velocity. So in every mechanical system, you have to represent both the displacement as well as the velocity, or it may be a displacement or it may be a acceleration.
So in the starting, you have told
Yes,
like that.
just same thing. I am also thinking about that. Maybe that actually here it is changed. I think mass it is resistance, the dashboard inductance. Actually, the mass should be inductance and dashboard should be a resistance. Here they are given wrong. The mass should be the inductance. Just to see this. Notice this. Force voltage, displacement, storage around mass. Mass is considered as inductance and resistance is considered as a dashboard. Here is wrong. So you please change this. So mass is inductance and a dashpot is the resistance. Dashpot is the resistance and mass is the inductance. So sorry for this confusion. I didn't note this down. So the change in the mass is represented by inductance and the dashpot is represented as a resistance. So the mass is represented by inductance and the dashpot is considered as a represented as a resistance. So for every mechanical system, you please note down there are the two representations. One is a displacement, another one is velocity, or it may be a acceleration. So you please go through this diagram. This is for force voltage analogy. For force current analogy, you have to change the voltage source into current source. As well as the voltage and current equations also will be differ. Because in voltage for the capacitance, it is a dV by dt. You please note on this diagram only. What is the transformation? Dashpot is converted into resistance, and the mass is converted into inductance, and spring is converted into capacitance. So for each mechanical system, there are two quantities to be represented. One is acceleration or velocity, another one is displacement. Can I move to the next slide?
One second.
So we are discussing how the force is converted into velocity. So shall I move to the next slide?
Yes.
So it is the analog quantities. The first one is the force is the input. The force is the input in mechanical system, and in electrical system it is a voltage. So next to the output is voltage and displacement of the output. Here the electrical system, current and the charge is the output. So here the dissipative element is dash part and the dissipative element is resistance, and the storage is mass M and the inductance is the storage element for in electrical system. So as usual, the physical law, that is the Newton's second law, the summation of all the forces will be equal to zero, and Kirchhoff voltage law, the voltage should be balanced. So changing the level of the input dependent variable is given by the lever. In electrical system, changing the level, that is a primary and secondary. Using the transformer, we can step up or step down the voltage. So this is a theoretical one. So only one thing is the changes to be made in the slide. So only one thing is the resistance, capacitance, and inductance. Capacitance means spring, and the inductance means mass. Resistance means dash spot. So this only have to be keep in the mind. Resistance, capacitance, inductance. Resistance means dash spot. Inductance means mass M, and the spring is represented as a capacitance. So next we are entering into the problem. So you please draw this diagram and please note down it consists of two quantities, displacement as well as the velocity is given in the diagram. So this is the practicing problem. Please draw the diagram first and note down everything. Your first step is find out the differential equation for the system. You already did in the mechanical translational system. For M1, derive the mechanical translation system. For M2, derive the mechanical translational differential equation. For M1, derive the differential equation. For M2, derive the differential equation. And tell me once you finished it, you move on to the next step. So first draw the diagram. The question is, draw the force voltage and force current analogous circuits. You have to draw both force voltage as well as force current and verifying by mesh and node equations. First draw the diagram. Put the first title, force voltage analogy. After that, we can go to the force current analogy. So if you have any doubt, please ask then and there. Because of this force voltage and force current analogy, if any circuit is given, you have to draw the equivalent electrical circuit for the mechanical system. So previously we discussed only the displacement. Now we have to consider the velocity also. So how many nodes in this diagram? How many nodes? How many nodes in this diagram?
Then
How many nodes? N-O-D-E-S, nodes. How many nodes in this diagram? Nodes. See, have you studied the circuit theory or not? How many nodes in this diagram? At least a mechanical translation system, based on the mechanical translation system, how we approach the problem. How many nodes in this diagram?
Two.
Two nodes. What are the two nodes? What are the two nodes in this diagram?
M1 and M2.
Yes, yes, exactly. M1 and M2. See, M1 and M2 are the two nodes in this diagram. So you have to remember that in electrical circuit diagram, also it consists of two nodes. Okay, M1, M2 in mechanical system has two nodes. In electrical circuit diagram also, you have to convert the nodes into mesh or loop. Two nodes means there should be a two loop in electrical system. Okay, so that is called as force voltage and force current electrical analogy. You finish this diagram. Shall you move on to the next slide? What is the next step? How to solve this problem? What is the first step?
Free body diagram of.
Yes, yes, exactly, man. Free body diagram for M1. So don't wait for others. You proceed the problem. That is, first take the M1 and draw the free body diagram for M1 and write the differential equation for the M1. So I ask you to write the differential equation for M1 and write the differential equation for M2. Shall I move on next slide? Shall I move on to the next slide?
Yes, sir.
Okay, I hope you have drawn this free body diagram M1. So with M1, you have to specify what are the applied force, what are the opposing force. You have to clearly specify what are all the applied force, what are all the opposing force. So based on that, write the differential equation and add the applied force on one side, opposing force on another side. So it will be very fast because you already practiced the mechanical translation system. First M1, next M2. Any doubt in this? Free body diagram for M1. So listen carefully. Here it is specified displacement as well as the velocity.
Sir, f of t and f of m1 will be in opposite direction, sir.
Yes, that force will be in opposite direction. Yes, exactly. The arrow marks should be in opposite direction. Four are the opposing force. Only one is the input force, that is applied force. F of t will be in a opposing force. Sorry, applied force. The arrow marks should be in opposite direction.
Sir, time over.
Time over. Hey, what can we do, man? What can we do?
Continue tomorrow, sir.
We need the special class because of if you solve the one problem means this 1 hour is not enough. We need the continuous 2 hours for the later problem. We need continuous 2 hours to solve the problem. So can we keep the special class 1 hour tomorrow evening?
No, sir.
No. When you are free, man? When you are free?
In the night, sir. So special class will give attendance.
So okay, man. See, you can wind up this session. You please solve the problem. That is M1 free body diagram. Write the differential equation. M2 free body diagram. Write the differential
Okay,
equation.
sir.
Okay. Stay on the line. What, man? This utterance is not showing. Only 3, 6, 7, and 9 only the showing. Can you able to see the screen?
Yes, sir. Yes, sir.
Only 9 of them. See, these students are your class only, yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Only 9 of them, but
Sir, first one is me, sir.
Ninth one is me, sir.
see, some of them written in Hindi. Padai hai, Kerlo bhai, Achi, Chense hai. What is the meaning of that, man? Anirban Ghosh.
Google, sir.
Google. See, who is Anirban Ghosh, man?
Sir, I am.
See, what is the meaning of that?
Sir, I told him to study. That's good.
So, okay, man, see, we'll take the utterance. Only 9 of them are showing. Okay, man, you can leave.
The attendance.
Attendance, sir.
Say, only 51, man. Out of 56, 51. I
Okay,
will
sir.
do
Okay, sir. Thank you, sir.
Sir.
Hello?
No, out of 50.
What about attendance?
Yes, man, out of 56, 51%.
No, okay, sir. Sir, can you just tell the numbers which are absent?
Here it is not showing, man. I will once again check manually.
Okay, sir, sure.
Okay, sir. Can we leave, sir?
Sir, because I had a small network issue in between, so I rejoined again. So that if it's
Okay, man,
not...
I have to check it because of I will record it manually only.
Okay, sir, fine. Fine, sir.
Thank you, sir.
Okay.
Sir, can we put in chat box, sir? Like we'll present or not?
No, man, that next time I will do that. So you put the roll number, present or not, like that, we can follow that.
Okay, sir. Thank you, sir. Bye,
Sir, will you share this PPT in the
Yes,
GC?
sir, the PPT. Okay, man. See, you solve the mechanical differential equation for M1 and M2. Tomorrow we can continue.
Yes, sir. Will you share the PPT, sir,
Yes, I share the PPT.
of this class? Yeah.
Yes, I will change. I will do some changes. The one slide, I will do some changes in the slide and then share with you.
Okay, thank you, sir.
Okay. Can leave.
Yes, sir.
Sir,
Yes.
so like the capacitor inductor that use, can you again explain like how the voltage is opposed in inductance?
See, inductance property is it opposes the rate of change of current. Okay. Inductance opposes the rate of change of current. That is the property of the inductance. Capacitance will stores the energy in the form of charge. Okay.
So like
So-
inductance, how the practically it is been working?
Inductance means if you pass the current to the inductance, what will happen? A magnetic field is produced around the coil, around the inductance coil, right? if you pass the current to the inductance, what will happen? A magnetic field is produced. But for capacitance, it's just the opposite. It is a electrostatic field or electromagnetic. The electrostatic field is produced around the capacitance.
No,
So
sir.
this is
After magnetic field, what is happened? Like after the
So
generation?
if there is any change of current, the magnetic property of inductance opposes the change of current. If there is any reduction or change in the current level, this inductance property will opposes the rate of change of current, di by dt.
The direction will change. The change in direction or change in magnitude will oppose.
The change in direction as well as the change in direction only.
Okay.
Change in direction.
So like finally the direction will get changed. If suppose in a circuit an inductance is there in parallel or in series.
Ah.
So I have connected a diode with the inductance, right?
Diode with
So-
inductance. Okay.
Okay. So when I'm like changing the direction,
Hmm.
like what happens? Like inductance will not allow the change.
Actually, inductance property is if I am applying the current, constant current and constant voltage to the inductance. So what will happen after supplying the power supply to the inductance? A magnetic field is produced around the coil.
Okay, sir.
Okay. Suppose if there is any change of the current direction, immediately it won't reverse it. It will oppose the direction of the current. After that, it will comes to zero. Then it will be start against to the maximum value.
So like why that is why we need in that circuit?
So the main purpose is to have the storage of energy. Inductance is a storage element, magnetic storage element.
So like, but the time is very less, no sir. Like,
Which one?
sir,
Time.
in inductance, it won't store energy for much time. Like, it will be in seconds.
Yes, see, actually, inductance and capacitance, both of them need some time to build up the energy.
Yes, sir.
Okay, so the time we have to continuously give a supply to maintain the storage of energy. We have to continuously continuity of the supply should be maintained. Otherwise, the energy will be decreasing step by step slowly.
Okay, sir.
I'll share the slide. I just to show you how to explain that. Just
Yes.
can you able to stay on the line?
Yes, sir. Yes, sir.
I'll show that the same inductance.
At 055 present, sir. I have network
Okay,
problem.
ma'am. Okay, ma'am. I'll see that. Later I'll see that.
Sir, I cannot hear your voice, sir, clearly.
Hello. Hello. Can you hear me?
Yes, sir. Yes, sir.
Just a minute, man. So can you see my screen?
No, no, sir.
Screen is. See, you are still in the same link, right?
Yes, sir. So like no sharing of screen.
Can you able to see the screen?
Now it is coming.
Can you able to see the capacitor transient response?
Yes, yes, sir.
You see that DC voltage is applied to the switch resistance and capacitance.
Okay,
So,
sir.
you see that what is the meaning of this means as the time t increasing, the
Yes,
voltage across the capacitor slowly building up. After it reaches the maximum charge, that is the maximum energy storage, it becomes constant. This is for capacitance.
Okay. So like after that maximum, it will pass the whole current.
After the maximum, no more space to store the charge.
But it
So
will
this-
pass the current to the rest of the circuit.
Yes, it will pass the current rest of circuit, but it will take time to build the charge, build the energy. This is for capacitance. So you
Okay.
see this tabulation. So this is for capacitance. First time starts from 0 up to 10. Battery
sir.
voltage is 15. Capacitor voltage starts increasing from 0, 5, 9, 12. At the same time, see, current is decreasing.
Yes, sir.
So the voltage is increasing slowly to store the energy, but at the same time, current is decreasing. Now, as per your point, inductance just opposite. Okay, inductance just opposite. Current will be increasing, voltage will be decreasing. See? Inductor voltage is decreasing, but
Like-
current is increasing.
Immediately it will charge up.
No, immediately not charge. What is the difference is, for capacitance, voltage is needed to build up the energy. For inductance, current is required to build up the energy.
Okay, sir.
Okay. Then second important difference what you said means, if there is any change of current, inductance opposes the change of current. That is, if there is any, not only the direction, the magnitude also playing a major role.
Okay, sir.
So that is the thing. So inductance, voltage is decreasing, but the current is increasing to build up the energy. If the current magnitude is reduced, means the inductance will not be able to store the charge in terms of magnetic field.
Sir, another question, like
Ah.
in a circuit, if the capacitance is removed, like what effect will be there?
So in a circuit, if the capacitance suddenly dropped,
So if capacitance is not there, like only rest of circuit is there without capacitance, like why the capacitance is built in the circuit?
so the main object of the capacitor is to store the energy, and also it will improve the power factor.
So like store energy means it won't be delivering energy for much of time, like
It will store and deliver. It will store and deliver, charging and discharging
like at a constant rate.
at a constant rate.
Okay, sir. Like if okay, sir. Like if source voltage is also less, it will deliver the constant.
Constant. It will discharge at a constant rate. Charging also constant rate.
For inductor.
It also the same thing. It is charging and discharging at a constant rate. For capacitance only we are worrying about charging and discharging. For inductance mostly we won't concentrate on charging and discharging. For
Okay, sir.
capacitance only we will talk about the charging and discharging period.
Okay, sir. Like if inductor is removed from a circuit, like what effect will be there after removing?
Actually, inductance is a one type of the reactance, inductive reactance.
Okay, sir.
So it means it is a characteristic similar to the resistance value.
Okay, sir.
So in what effect the resistance having, inductance also a same effect. That's why it is called as inductive reactance.
So, but like why we are using, then we can use a resistance instead of inductor.
Sometimes if your voltage is very high, means what will happen to the circuit elements?
Okay, sir.
Sometimes the current will be very high. That's only we will in our home we are saying that it is a over voltage.
Yes, sir.
It is a low voltage. So if in your home is, suppose if your home is situated near to the substation, means you will face over voltage.
Okay, sir. So why like?
Because of substation is near to you. Suppose if your home is far away from the electricity board, means you will face the low voltage problem. So in such cases, if it is over voltage, means we have to install the inductance
Okay, sir.
to observe the excessive voltage or excessive current, to observe.
Okay, sir.
Capacitance means if you are in your home, you are facing a low voltage problem, you have to connect the capacitor. It will store the energy and gives the energy at the time of low voltage.
Okay. Like it will be directly in series with the voltage.
Or series or parallel. That depends upon the load condition.
Okay, sir. Okay, sir. That's
Okay.
it. Yes,
So
sir.
you can see the second point. When capacitors are placed in a circuit with other source of voltage, they will absorb energy from the other sources.
Okay, sir.
It acts as a battery.
These all are in our syllabus only.
Yes, actually, now your second year, yes, that's only last year I handled first year subject, BEEE, Basic of Electronics Engineering.
Like this was in the last syllabus, and the classes got suspended.
Last semester only you studied BEEE,
Yes, sir.
Oh, God, just only I know, man. See, actually, you were who is your teacher?
Sir, the Shiva Prasad, sir. Like what happened? Like due to COVID, they suspended the classes, no, sir.
Okay. Actually, you are in a second semester, right? When you are in first semester, I handled the BEE subject.
Okay, sir. Can you just send the PPT that?
Definitely, say, sir, man. Now only I'm realizing that. So, okay, now I understand your problem. That you are not studied, not able to cover all the part. Okay,
Yeah,
actually, when you are joined in the first semester, you have the basic civil and mechanical engineering, right?
yeah, sir.
Oh,
In the
in second semester, you are studying basic electrical electronics engineering.
yeah, and
Exactly.
half with the half syllabus we like.
Oh, okay, half our syllabus completed and half our syllabus unable to complete it. While you
Yes.
are in first semester, at that time I handled a BEE for a CSC D2 section.
Okay, sir.
D2, I think the D2 section is a networking section, computer networking. Okay,
So
man, I will share the slide definitely.
I'll message you in WhatsApp. Please share that number.
Okay, man. Okay, definitely. Or I share in your group because all of you must study the circuit theory basics. It is better to share all the slides with you. Okay.
Yes, sir.
I'll share in the control system group and put that this is a BEE course. Those who want to study can take parallel.
Okay, sir.
Okay, your name, man? Good name?
Sir, Lokesh, sir.
Okay, sir. Tamil, which state?
Telugu, sir.
Huh?
Telugu.
Telugu, I am also Telugu, man.
So where are you from?
Actually, I am native Tamil Nadu, but I am a Naidu, Gaura Naidu.
Okay, sir. Sir,
Okay,
like where?
Huh?
I'm from Srikakulam district.
Srikakulam district, but my native is Tamil Nadu, Madurai.
Okay, sir.
Okay, man. Okay, sir. Thanks. Keep in touch. Okay, I will share the slide definitely. Thanks for your information.
Yes,
Okay,
sir.
man. Thank you.